So after recording this video, I realized I had the strategies in the game on the right wrong. On the problem set, I have a C here and a D here. So sorry about that. This will be a little bit annoying tracing it back, but just, keep straight. What's the strategy for the game on the left, strategy for the game on the right? And in your solution, write it in terms of C and D. Okay, so we're in the world of simultaneous move games of incomplete information. So in this problem, person 1 doesn't know if we're playing the game on the left or the game on the right, but person 2 does. So person 1 believes that there's probability 1/2 we're playing the game on the left, probability 1/2 we're playing the game on the right. With all these problems, we're starting with what are the strategies for the players. So player 1 is pretty simple. So in general, it needs one of these people is going to have a more complicated strategies. One's going to have a simpler strategy. It's always the person who knows more who has a more complicated strategy, because a complicated strategy is just an if-then statement, and you can only do an if-then statement if you know something. So this is the form: if it's the game on the left, I'm going to play something. So the only person who can say that is the person who knows whether it's the game on the left or not. So in this case, the person with the simple strategy is player 1. So they're either top or bottom. The person with the more complicated strategy is player 2, because player 2 knows whether it's the game on the left or the game on the right. So player 2's strategy looks something like, well, as follows. If it's the game on the left, I'm going to play A. If it's the game on the right, I'm going to play B. Something like that. So there's 4 possible strategies. We'll write them down. All right, so there are 4 possible strategies. And the challenge in these games is always filling out this table and then doing underline the best responses. There's several challenges. These are hard problems. Figuring out what strategies are, who has the more complicated strategies, filling out the tables, best responses. So I'd say all these are pretty challenging. We know that it's going to be hard to fill out the table. We know there's 2 different ways of doing it. And so for this problem, we'll do it both ways. The multiple personalities, where we're treating the person who knows it's the game on the left as different from the person who knows it's the game on the right. We'll also treat it with just 1 player over 2, both ways, so you can see it for this particular problem. The other ones we'll just do it one ways. Let's pick a strategy. So might as well start with TAA. And we're just figuring out how it interacts. And maybe it'll even help you to write down, so game on the left versus game on the right. So in the game on the left, so 1's playing 2, 2's playing A, and the outcome is just 3-2. That's what happens in the game on the left if 1 plays T and 2 plays A. On the right, if 1 plays T and 2 plays A, the outcome is 1-2. And so there's a 50% chance of the game of the left, 50% chance of the game on the right. So for player 1, there's probability 1/2. They're on the left, and then they get 3. With probability 1/2, they're on the right, and then they get 1. So player 1's expectations in this are just 2. And so here we'll do this as the multiple personalities way. Now we don't have to do expectations. So for the player 2 on the left, she's getting 2. For player 2 on the right, she's getting 2. So this would be 2, 2, 2. So now let's do the next box, TAB. So again, on the game on the left, player 1 is playing T, player 2 is playing A. And the outcome, if 1 plays T and 2 plays A, is the same as before. It's 3-2. Now on the right, player 1 is playing T, player 2 is playing B. And the outcome on the game on the right, when 1 plays T and 2 plays B, is 5-0. All right, so there's 3 payoffs we have to figure out. The hardest one is player 1. So player 1 is getting 3 half the time and 5 half the time. And so that means their expectations are 4. So it's just 3 times 1/2 plus 5 times 1/2. Player 2, the one who knows it's the game on the left, is getting 2. And the one who knows it's the game on the right is getting 0. So we fill in all the boxes that way. If you want, just write it to the side. So what player 1's doing, what player 2's doing on each side, and just write down the payoffs. And just be a little slow and careful with it. That doesn't take that long. But after we've done all these are the numbers that you should get. Okay, so let's do one more just to make sure we're all on the same page where these numbers are coming from. So let's pick, say, B, A, B. All right, so player 1 strategy is to always play B. Player 2 strategy is if it's a game on the left, I'm playing A, and if it's a game on the right, I'm playing B. So let's figure out the game on the left. So 1's playing B, 2 is playing A. And so if we go up, so 1's playing B, 2's playing A, so that means we're in this box, so the outcome is 2-2. Now the second game, we have 1 is still playing B, so 1's only playing one thing, B, but 2 is now playing B, and so now we're in the game on the right, 1's playing B, 2's playing B, and so the outcome is 3-3. And so we put these numbers together. For 1, half the time they're getting 2, half the time they're getting 3, so their expectations are 5/2. The player 2 that knows the game on the left is getting 2, the player 2 who knows the game on the right is getting 3. All right, so now we have our table. Now we have to underline best responses. So let's start with player 1. So what's player 1's best response? Because player 1, I think, is the easiest. So you're responding to a strategy from player 2. So, for example, one strategy is AA. Now we look at which of these numbers is player 1's payoff, and so it's the first number. And so player 1 can get either 2 or 1. So the best they can achieve is 2. So T is the best response to AA. So for AB, you can get either 4 or 5.5. So 4 is the biggest number. For BA, well, either way, the way you do it, you're going to get 1/2. And so now it doesn't matter. Either one's the best response. Now we can either get 2.5 or 2. So top is the best response. For player 2, I always find this to be the tricky part of this question, because now there's 2 different player 2s. There's the player 2 that knows it's the game on the left, and the player 2 who knows it's the game on the right. So let's start with the player 2 who knows it's the game on the left. So they're responding to a strategy from player 1. So for example, top. And so the player 2 who knows it's the game on the left can either get 2, 2, 4, or 4. And so 4 is the best they can achieve. And there's 2 different ways they can achieve that. And now we look at the second player 2, the player 2 who knows it's the game on the right. They can either get 2 or 0. So 2 is the best they can achieve. There's 2 different strategies that give them. And if they're responding to bottom, they're either going to get 0 or 3. So 3 is the best they can achieve, and there's 2 strategies that achieve that. All right, so now we've done all our hard work. And so what we found, we're looking for mutual best responses, and there's 1 where all are underlined. And so our Nash equilibrium is just top for player 1 and BA for player 2. Okay, now let's do it the other way. And obviously, if you prefer the first way, just skip this section. But just so you get so the people who do it different ways figure it out. Player 1, nothing has changed, so the payoffs are exactly the same as they were before. So let's put them in. It's player 2 that's different. And so for player 2, now we're going to treat player 2 as just one person. And half the time it's the game on the left, half the time it's the game on the right. So let's take, again, any of these boxes. So I might as well start with the upper left. So top AA. And so for player 2, half the time it's the game on the left. And when it's the game on the left, player 1's playing top, player 2's playing A, and the outcome is 3-2. So for player 2 is getting 2. The other half the time, we're the game on the right. So the game on the right, when 1 plays top and 2 plays A, the outcome for 2 is 2. So half the time they're getting 2, half the time they're getting 2. Their expected outcome is 2. All right, now let's look at another box. So let's look at top AB. So in the game on the left, 1's playing T, 2 is playing A, and so 2 is getting a payoff of 2. And that occurs half the time. The other half of the time, we're in the game on the right, and now 2 is playing B. So 1 plays top, 2 plays B, the outcome is 5-0, and 2 is getting 0. So the payoff for 2 in this particular case is 1, the expected payoff. So we fill in the remaining payoffs that way. So after we do it, these are the numbers that you should get. So I personally find that it's harder to figure out, for me to figure out the expected payoffs of 2, but our reward is once we have it down, now underlining best response is a lot easier. So we underline the best responses of 1, what's 1 reverse. So again, 1's responding to a strategy for 2. So response to AA is either 2 or 1. So top is the best response. Top is going to be the best response to AB. For BA, it doesn't matter. For BB, you have 2.5 or 2, so top is the best response. For 2, now we only have one player 2 to worry about, so this is the part that's a little bit easier. So suppose responding to top, we're choosing between 2, 1, 3, or 2. So 3 is the best we can achieve. BA is the best response. Now if we're trying to B, 1, 2.5, 0, or 2, so 2.5 is the best we can achieve. So that's our best response. So our Nash equilibrium, where everything's underlined, is here. So our Nash equilibrium is T for player 1 and BA for player 2.